Hello, welcome to our very first lesson in summer stats. We're going to begin in chapter 1, discussing some basic terms about sampling and data in general. So in this chapter we have a few objectives that we want to meet. Basically we're just going to try to start with some key terms, some definitions, and then we're going to talk about various sampling methods, ways to collect our data, and then we're going to talk about frequency tables, which are one of the more interesting and useful ways to begin organizing data. So in section 1, again, we're going to start with a lot of definitions and some terms. And to start with the most basic, that would be data. Okay, data take on a broad range of possible types and styles and characters, but in general, just a simple definition is data is a collection of observations. Now, statistics, the class that you're in, is basically what we do with data. So how we collect it, how we organize it, how we do math on it, and then one of the more important things about it is we need to be able to present it to people who may not really know anything about statistics. So stats is kind of a unique math in that way. Very rarely, do you need to graph a polynomial and then be able to present that graph of a polynomial to someone else, right? That's just not typically what we do. But in stats, most often we're doing something regarding data that has value to people outside of just ourselves. So we need to be able to present that data and help people understand it. There are two primary branches of statistics. The first is called descriptive statistics, and the second is called inferential statistics. Descriptive statistics basically just we find the mean, we find the standard deviation, perhaps we find the z-scores for individual data points, but we don't try to make any kind of conjecture about what's happening in the entire population as a whole based on the few pieces of data that we have. We're just describing things. In inferential statistics, we take a sample and we use that sample to make some sort of a inference about the population as a whole. So we're going to start with some descriptive statistics, and then we're going to spend a good bit of time talking about probability and probability distributions, and then finally we'll be able to get to some inference toward the end of the course. So while we're at it, probability is basically dealing with how likely an event is to occur. All right, in a nutshell, that's what probability is. And some probability situations are pretty simple. How likely are you to roll a 6 on a standard 6-sided die? Right, that's a fairly simple probability idea. But they can get a lot more complicated. Later on in the course, we'll see examples of, how likely are you to pass a multiple choice quiz if all you do is guess, right? That's a little more complicated scenario because maybe there's 10 questions and there's 5 choices per question, and what's the probability I pass the quiz? So probability takes on a lot of forms, and we'll spend a good bit of time making sure that we really understand what's happening with probability. Probability is important. There's a lot of professions, a lot of careers where you may use probability. One example would be civil engineers. Okay, designing a building in a particular location, they need to know what's the probability that that location will see a flood or a tornado or a hurricane or an earthquake, things like that. So lots of different careers use probability on a day-to-day basis. So some key terms here. Population is maybe kind of obvious, but at the same time, some people just jump straight to like the population of the United States, right? Like the population is everybody. And that's a good way of thinking of population. It is everybody, but it may not necessarily be everybody in an entire country. We might just be interested in the population that represents the senior class at North Cobb Christian School, or the population might be all of the gallons of milk on the shelf at a particular store, or something like that. It doesn't have to be people, and doesn't have to be people in an entire country. It can be a fairly limited thing, but the population is always all of something. Whereas a sample, on the other hand, is where we are just selecting a few. Well, it might be more than a few, it might be a lot, but it's a subset of the population. Okay, it's not everybody. Sampling is just the way that we acquire a sample. A statistic, and this is a little different from statistics with an S on the end. A statistic is a numerical characteristic of a sample. Okay, so if I take a sample of 10 items and I come up with an average of their, let's say, weights, okay, that average weight is a statistic because it's talking about a sample. On the other hand, a parameter could be a mean or an average, or it could be some other number, but if it's a parameter, then it's specifically talking about the entire population. Okay, so say I wanted the mean GPA of all seniors, okay, at NCCS. So in that case, because I'm talking about all of the seniors at NCCS, that would make it a parameter. Okay, in that case, my population is all seniors, and since I'm talking about the average of all seniors, that makes it a parameter. All right, so a representative sample is basically just saying that a sample that we have collected does a good job of representing the population. So, in other words, we don't have a sample that's full of unusual values. We have a sample that gets a good cross-section of the entire population and therefore represents everybody in the population pretty well. Pretty much never are we going to be able to guarantee that we have a representative sample, but most of the things that we do when talking about sampling and trying to use sound methods for collecting samples is with the goal of having a representative sample when we're all done. Going to go through these a little quicker here. Variable is basically, we usually use X for the variable, and it is a value that every member of the population, or that can be found for every member of the population. Okay, so for example, maybe I want to find the mean height of people on the cross-country team. Okay, so what I would do is I would ask everyone on the cross-country team, how tall are you? All right, that would give me a data point for each person. So the variable in that case would be the height of an individual. Okay, so I would take the heights of all these individuals and I would find the average, and that would give me what I was looking for. Okay, so the variable itself that I would probably call X would be the height of each individual person. Okay, so you have to make sure that when you are identifying a variable that you're identifying something that can be found for each person in the population. Okay, the variable would not be the mean height. Okay, that would be a statistic. The variable is the height of each individual person. Okay, that's the variable. So variables can take on either numerical values or categorical labels or names. So we'll talk more about that, the difference there, in a little while. Data. So data is the actual numbers or answers themselves. So, if I asked someone on the cross-country team and they told me that their height was, let's say, 68 inches, then that would be a particular data value, the 68. Okay. All right, so mean, I think we probably know what a mean is, but just in case, it's where you add all the values up in your collection, in your sample, or in your population. You add them up, divide by the number that you have, and that's our mean. That's technically called the arithmetic mean, and that's pretty much what we deal with all the time. A proportion is like a fraction of the population. So these kinds of statistics you see a lot when dealing with politics. People ask, are you pleased with the president's performance? and people say yes or no, and then the news anchor comes back and says, 49% of people are pleased with the president's performance right now. Okay, that 49% is a proportion. All right, so for example 1.1, I'm referring to this as 1.1 because that's how it's labeled in your textbook. So if you want to go and look at this in the textbook, you're looking for example 1.1. Basically, we want to pick out the key terms here. So the statement is we want to know the average or mean amount of money first-year college students spend at ABC College on school supplies, not including books. We randomly surveyed 100 first-year students, and 3 of those spent $150, $200, and $225 respectively. So first thing we want to figure out is what's the population here? Well, we're specifically told we want to know the average for first-year college students at ABC College. So our population is all of the first-year college students at ABC College. Our sample would be the ones that we specifically spoke to. So we randomly surveyed 100 first-year students, so that would be our sample. The sample would be the 100 first-year students. A parameter, the parameter would be the average amount for all first-year college students. Statistic would be the average for the 100 that we sampled. Okay, so that the mean amount of money for the 100 college students we spoke to would be the statistic. Our variable, remember this is something that has to be a number we could get from each person individually, so our variable in this case would be the amount of money each student spent. Okay, so we would call that X, the amount of money spent by an individual student. Data, so we actually do have 3 pieces of data in this little scenario. Okay, the 150, the 200, and the 225 are our data values. All right, so a couple of homework problems are just like this, and so hopefully that kind of gives you a good idea of what you're looking for as you go through these pieces. I want to take a moment here. This suggested homework, these are just a few problems that I recommend you go look at. There is no homework collected in this course, so these homework problems that I suggest are purely for your benefit in preparing for quizzes and tests. Notice that I'm not putting, I don't think, well, just in case I didn't mention this in the intro meeting, our textbook splits homework into 2 sections. There's a practice section and a homework section, and all of those are at the end of the chapter. Okay, so you don't see homework questions in between sections in our textbook. They're always at the end of the chapter. And sometimes I prefer questions from the practice section, and sometimes I prefer questions from the homework section. So in this case, I'm pulling from the homework section. But it doesn't make sense in our case to put page numbers like page number 10, numbers such and such, because depending on whether you're looking at the online version or the Perusall version or the PDF version, all of those may show you different page numbers for some reason. And in fact, I think the online version, if you go to OpenStax and you look at the online version, I don't even think you can see page numbers. So instead of page numbers, I'm either going to label your homework as coming from the practice section or the homework section. All right, so we'll wrap this video up here, and we'll pick it up next time with section 2.